angle, the type of angles that we are dealing with. So we have an angle here. We have angle AOB. And then you realize that before AOB, there's a symbol here. This symbol means that the angle is formed at point O. So when you look at the drawing here, at point O is where the lines meet. So when you see a symbol here with this with this symbol here, where the points meet will be in the middle here. So it's telling us that the angle is at point O. So you read it as angle AOB, right? And this angle, we are saying is less than 90 degrees. And if it's less than 90 degrees, it's an acute angle. All right, it's an acute angle. So then we have the right angle. And you know, this, the name of that triangle we call right angle triangle is as a result of this. You see, when you add a third line here, you get a triangle, right? So that becomes the right angle triangle. But here we are only talking about the angle. So this is a right angle. And the right angle occurs at point O. So we have angle DOB, which is equal to 90 degrees. So if you have an angle that is 90 degrees, it's called right angle. So you read this as angle DOB is equal to 90 degrees, all right? So we also have obtuse angle. And an obtuse angle, we say, is an angle that is what? The angle is greater than 90 degrees, but less than 180 degrees, right? So FOE is less than 180 degrees, but greater than 90 degrees. So the angle is here, AOB. Sorry, FOE. Okay. So there's a FOE, angle FOE is greater than 90 degrees, but less than 180 degrees. That's how you read this expression here. Okay. So we have straight angle too. And straight angle is a straight line. And we are saying that the angle on a straight line is 180 degrees, right? So here we have angle POQ. So here we are saying is 90 degrees. So here, though it's a straight line, we can equally say that from here to here is a line. From here to here is a line. So they are joined at this point. Sorry, they are joined at this point. So at this point that they are joined, they are forming an angle here, which is 180 degrees. Okay, so we also have reflex. This is a reflex angle. And then we are saying that a reflex angle, and this angle is formed at point O. So we have angle LOM. And it's saying that this angle is greater than 180 degrees, but less than 360 degrees. You got it. You realize that as this line goes straight, it diverts to this point again. So it doesn't go straight to make 180. It extends here. So this extension makes it greater than 180, but less than 360 degrees. And that is a reflex angle. Okay. So we know that the sum of angles which meet at a point is 360. You all agree with me that a circle, right? A circle has an angle of 360. So when we have more lines meeting at a point, you realize that this we have three lines here meeting at a point. When you put these three lines together, it forms more or less like a circle. It forms more or less like a circle. So when these three lines meet, the sum of all these angles, the sum of all these angles should give us what? 360 degrees. So when you add A to B to C, it's reasonable to equate it to 360 degrees. You get it? All right. So we have here another example here where we have four lines meeting at a point. And when you add all these four angles, you should get 360. Here, one of you noticed that one of you reached out to me and noticed the summation here, and I was grateful for that. So when you sum all these angles, you are supposed to get 360 degrees. So when you add 100, you add 120, and you add 20, you get 240, right? So you add, you group like terms. So this A will be on one side, and then you have your 360 minus 240, and that would give us 120 degrees. I hope you all noticed that in the video there was instead of 120, it was 20 degrees. So there was an omission there, and one of you reached out, and I was grateful. I hope you all noticed that, or some didn't know. Did you notice it?
Yes, madam.
Okay, that is good. That means you understood that that's how it should be. That's good. If you didn't notice it, that means you didn't understand it. So you have to go over it again. So we'll move on. And then as I said that we have for a straight line, right? A straight line has an angle of 180 degrees. So if you have an angle of 180 degrees, and then you are given some parts of the angle, you should be able to equate it to 180 and get the angles that you are to find. So here, we know that the angle of a straight line is 180. So if you have this, you simply sum it all and equate it to 180. And here we have done that. And then when you group like terms, you have 180 degrees minus 100 degrees. And your x becomes 80 degrees. So here, if you want to prove or know whether your answer is right, you can simply add 30, 70, and 80. And you should get 80 degrees. If you add them and you get more or less 180 degrees, that means there's a problem with your answer. Okay. All right. So we'll look at triangles to form angles because they also have lines meeting at 3 points. And then because we have learned some we are going to learn the angles, triangle forms, and then the names of the triangles based on the angles that they are formed. And then we know that the sum of interior angles of triangles is 180 degrees. No matter the triangle, all the three angles that they form, when you sum it up, you should get 180 degrees, irrespective of the type of triangle. Okay, so we have equilateral triangle. And then we are saying that equilateral triangle has all the properties that we listed is that it has all sides equal. So when we say all sides, we are talking of this side, and this side. All the sides are equal, right? And because of that, all the interior angles too are equal. All the interior angles are equal. So we have 60, 60, 60. So if you have an equilateral triangle and you are given one angle, only one angle here, you should know that that one angle will apply to all. They are all the same, right? And then we say it has 3 lines of symmetry. The lines of symmetry are the dotted lines in red, right? So we have 1, 2, and 3. And we are saying they are lines of symmetry because you see, it divides the angles equally into 2, and it also bisects the line opposite it. So it's at this line of symmetry has bisected this angle and bisected the line opposite it. Same applies to this. Though this triangle is not drawn to scale, but if it were to be drawn to scale, you see it's exactly as I'm saying. So this has also divided this, it has bisected this angle and it bisects this line too. So it has 3 lines of symmetry. You can always be asked how many lines of symmetry does equilateral triangle has. You should be able to say that it has 3. And then we will look at isosceles triangle. For isosceles triangle, we are saying that it has 2 of its sides equal. So one side here, one side here. For this particular triangle, we have this side and this side to be equal. And because of that, it also has 2 interior angles to be equal. So we have 2 interior angles. We have A degrees and A degrees to be all equal. And we have 1 line of symmetry bisecting the base and the angle opposite it. So you see here, we have only 1 line of symmetry. It's bisecting this angle and it bisecting the angle here. You see, because it has only 2 sides equal, it can't have 3 lines of symmetry. You realize that when you bisect this angle here straight, it cannot bisect the angle opposite it equally. It won't happen here. Neither will it happen here, right? It can only happen at one point. So you can have it bisecting the line opposite it from the apex here. So we have only 1 line of symmetry. Okay, all right. So we'll move on to right angle triangle. And you remember the angle that we talked about, the right angle. So when you have an angle here with 90 degrees, that means that this is a right angled triangle. So here it will be constant 90 degrees. And since we said that an angle has a sum of, the sum of the 3 angles of a triangle is 180 degrees. If we have here to be 90 degrees, that should tell us that what? This will be 45 and this will also be 45. I hope you agree with me on that.
Yes, madam.
Yes, please.
All right. So we have a right angle triangle has 1 interior angle equals to 90 degrees. Okay, then we have scalene. As for scalene, it has all sides different in length. All sides are different. It doesn't have any, and because of that, all interior angles are different. All interior angles are different, and it has no line of symmetry. It's impossible to have this, an angle bisecting an angle and bisecting the line opposite it equally. When you look here, assuming I'm trying to get a line of symmetry here, it will never be able to bisect the angle equally. You see? If you have it here too, it can't have it equal. All right, so I hope you have that properties in mind. And with that information, you should be able to solve problems that comes with angles and triangles. So you need to have that properties in mind, the properties of the angles, the properties of the triangle, so that when you are given a triangle, based on its property, you can apply that to solve problems. So here we have an example of an isosceles triangle. You see this dash here, this should tell you that this line and this line are equal. So if you have these two lines equal, 1, 2, that means we are talking about an isosceles triangle. And we've been given some angles and we haven't been given some angles, and we are asked to find them. So the knowledge of the angles and triangles should give you the information to be able to solve this. So first, we want to find angle A. Angle A. So since the triangle is isosceles, the other base is 56 degrees. So we are talking about the triangle. We are saying that it is isosceles, right? We are saying it's isosceles. So if it's isosceles, that means that, hold on. If it's isosceles, that means that we have here 56 degrees. That means this particular part will also be 56 degrees, right? So we have 56 degrees here, and we have 56 degrees here. So in order to find A, we know that A plus 56 is equal to 180. You realize that in as much as we know that this is 56 degrees, and this line is forming, it's a straight line. It's a straight line. We have a straight line here. So this plus this should give us 180. A degrees plus 56 degrees should give us 180, isn't it? So we have A plus 56 degrees is equal to 180 degrees. You group your like terms and you have 124 degrees. So A here is 124 degrees. We have applied the rule there. We have applied the properties of a straight angle of a straight line. That's how come we've been able to know that it's 180, and then we equated it and we had 124 degrees, right? Okay, so if we want to find B, as we said, the sum of interior angles of a triangle is 180 degrees. And we have established that this is an isosceles. So here is also 56 degrees. This angle here will be 56 degrees. So when you add all the interior angles of the triangles, you equate it to 120 degrees, then you'll be able to find your B. Okay, so we have here B plus 56 degrees plus 56 degrees equal to 180 degrees. So our B is what? 68 degrees, right? Okay.
Yes, madam.
We also look at C. We have C here. We need to find C. And we know that this is 56 degrees. We have 56 degrees here, right? So this is also a straight line we have here. And we know that the sum of the angles on a straight line, the angle on a straight line is 180 degrees. So when you add up 56 plus C plus 19, you equate it to 180 degrees. And you group your like terms, and we have 105 degrees. So that means C here is what? 105 degrees, right? Okay, so having solved that, let's see. I think we have, we are moving on to Pythagoras theorem. And this theorem is about right angle triangle, right? And we are saying that the Pythagoras theorem is saying that the square on the hypotenuse, and this is the longest side of the triangle is the hypotenuse. This is the hypotenuse. is equal to the square on the hypotenuse is equal to the sum of the squares of the two sides. So we have an equation here which is telling us that the line AC, the square of the line AC, right, is equal to the sum of the square of the opposite side. So the square of line BC plus the square of line AB is equal to the square of line AC, right? So we have it here. That is what the the Pythagoras theorem states. So assuming the line AB is A centimeters, we have here C centimeters, and we have here B centimeters. So we have A squared is equal to B squared plus C squared. That is what the hypotenuse is telling us. So this is an example. We'll look at it before we look at the exercise that we gave out. So here we have been given an angle. We have been given a right angle, and the sides we have 12 centimeters and we have 5 centimeters, and we've been asked to find B, which is the hypotenuse, right? So by the theorem, we know that B squared is equal to what? 12 centimeters squared plus 5 centimeters squared. So we have B squared is equal to 144 centimeters squared plus 25 centimeters squared, right? Okay, so we know that the B squared is equal to 169 centimeters. We've added this to this centimeters squared. So here, in order to get our B, we need to remove these squares. So in order to remove this square, you introduce the square roots. And the square root is the same as raised to the power half. So from this slide, I'll explain that part more so that those who don't really understand the square roots and it's how to use it would understand it better. So here, you introduce the square roots. And when you introduce the square roots, which is also the same as raised to the power half, it cancels out your square. So we have B is equal to the square root of 169 centimeters squared. You get it. So this will give us 13 centimeters. So our line AC, which is B, is equal to 13 centimeters, right? Okay, so let me take this opportunity to explain how the square root works. So the square root, as I said, is the same as raised to the power half. So if you have B squared equal to 169 centimeters squared, and then you introduce raised to the power half, this is how it will look like. So you have B squared raised to the power half is equal to 169 centimeters squared raised to the power half, right? You should note that this centimeter squared is for this one alone. It's for centimeters squared. And then 169 is also on its own. So you have 169 raised to the power half times centimeters squared raised to the power half, right? Because let me go back and explain something here to you. You had 12 centimeters into brackets raised to the power half. So, and then we had, we were able to get 144 centimeters squared plus 25 centimeters squared. And we had what? 169 centimeters squared. What you should note is that this squared applies to this centimeter squared and it applies to this 12 squared. You get it? So it's this 12 squared that gave us 144 squared. And centimeters squared gave us centimeters squared here. It's the same thing here. This 5 centimeters into bracket, the squared, we have 5 raised to the power 2, which gave us 25. And then the centimeters squared gave us centimeters squared here. You get it? That is how come we had 169 centimeters squared. So here you should note that this squared that you have here, it's not applying to this because this one has already been worked out. It's the centimeters that still has the square. Okay. So if you have b squared is equal to 169 centimeters squared. If you have any questions, when we are done, you, as we said last week, would answer all questions, okay? So I'll attend to you when we are done with the discussion. So you have b squared raised to the power half is equal to 169 centimeters squared raised to the power half. And the half, this 2 will cancel this 2, and then we'll have 1. And then we have the centimeter squared to this will cancel this. Then we have 1. And this is the same as this. So this is how it looks like. So you can equally use your calculator to find 169, the square root of 169. Because I told you that square root is the same as raised to the power half. So this is how it looks like. So we have 13 centimeters. You see the squared here we have cancelled. So it's no more squared. It is now centimeters. So you have b is equal to 13 centimeters. Or you can use your square root straight away, where you have the square root of the b. You introduce the square root straight away. And then you know that this 2 will cancel the square root out because I said square root is the same as raised to the power half. So when this 2 cancels the square root, you still have your b, and then you have your 169 centimeters squared. And this is the same as b is equal to what? The square root of 169 and the square root of what? Centimeters squared. And this centimeter squared, this will cancel the roots, which is the same as raised to the power half. And then you have 13 centimeters squared. Go and use your calculator to find the square root of 169 to give you 13. And we know that our centimeter squared has already been cancelled with the square root, so it becomes centimeters. So that is how the square root works. I just wanted to take you through this so that you understand it better and you know when and how to apply it. Okay. All right. So this is the exercise we gave out, and then we'll go through the exercise and then. But before that, before we go through the exercise, any questions? Any question? There was a hand raised, Shiloh. I don't know if you still have a question.
Yes, madam. Please, can you go back with a slide, one step over there? You realize that when you go to the B,
Here.
yes.
Are you okay
Please.
here? Okay.
Please, not this side.
I should keep going.
Yes, please.
Okay.
Yes. So please, that's okay. One. On the 4th step, realize that it is B is equal to square root of 169 centimeters square, and I'm
Yes.
asking, is the B supposed to lose its square or not at that stage?
You know, at that stage, we are looking for B. We are not looking for B squared. So
Okay.
when you are asked to do this Pythagoras theorem, because
Yes.
of the way the formula is, the formula has squared. So if you are to find B, you have to break it down to B. You are not looking for B squared. You have to break it down for us to have B, not B squared.
Yes,
That
please.
is why you have to introduce the square root to be able to break it down.
Yes, please.
Do you understand?
Yes, please.
All right.
Thank you.
You're welcome. Any more questions? So that we go through the exercise. Simon. Simon. Simon.
Yes, can you hear me?
Yes, I can hear you.
Okay, please, madam. I wanted you to go back on the beginning.
Beginning.
Go back to the beginning because I don't understand very well because I just came. I didn't got what you did before this one.
Beginning of what?
This course.
Wait, you said I should go back to the beginning of what?
This one.
This Pythagoras theorem.
Yes.
Oh, okay. So I should go over the Pythagoras theorem for you.
Yes, madam.
All right, no problem. I'll go over the Pythagoras theorem for you. Okay.
Yes,
We
madam.
are saying that
Yes,
this
madam.
theorem is about a right angle triangle. And
Yes,
then the
madam.
theorem has its how do you call it? An equation that goes with it. And we are
Yes.
saying that it usually deals with right angle triangle. And then
Yeah.
a right angle triangle, the longest side is the hypotenuse,
Yes,
which is
madam.
on here. So it's
Yes.
telling us that the square root, right, of the
Yes.
longest side here,
Yes.
the square of the longest side is equal to the sum of the square of the other two sides. So the other two sides are BC and AB. So we are saying the line AC squared, which is the hypotenuse, is equal to line BC, which is here, plus line AB squared, which is also here, right? So that is what the theorem says. So assuming that line AC is A centimeters and line BC is B centimeters and line AB is C centimeters, then we can say that A squared is equal to B squared plus C squared. That is what the theorem says. And then whenever you are given a problem and it's a Pythagoras problem, you need to apply this to be able to solve it. So we gave an example here where we have a triangle, a right angle triangle with line AB 12 centimeters, line BC 5 centimeters, and line AC B. We don't know line AC. So we are asked to find line AC. And from here, we know that line AC is the what? Hypotenuse. So applying the Pythagoras theorem, you realize that you have B squared, which is the hypotenuse, is equal to 12 centimeters squared plus 5 centimeters squared. So that would give us B squared is equal to what? 144 centimeters squared plus 25 centimeters squared. Okay. And that will give us what? B squared is equal to 169 centimeters squared. Okay. And that's because we are looking for B, not B squared. We have to introduce the square root in order to cancel the square out. So when we introduce the square root, we have B is equal to what? 169 centimeters squared. and that is what? 13 centimeters, right? Okay, so that is about it. But I went on and said that because from this step to this step, I wanted to explain the square root and how it works for you to be able to know when and how to apply it. So I was saying that if we have d squared is equal to 169 centimeters squared, and we want to find b. We are not looking for b squared, we are looking for b. So I was saying that the the raised to the power, the square root, whenever you see square root, is the same as raised to the power half, right? So when you raise the power half here, when you have b squared raised to the power half, this cancels out your square because this 2 here will cancel this 2 here. And you have, if you have any number raised to the power 1, is the same as the number. So when you have this half canceling this 2, we have b raised to the power 1, which is the same as b. So we have your b, and we know that this 169 centimeters squared is the same as 169 raised to the power half and centimeters squared raised to the power half, right? Because this squared here is only applying to this centimeter squared. So you need to understand that this squared is not applying to 169. It's applying to centimeters here. Please, do you understand me? So that when you have, when you introduce the square, maybe I should have put this one in brackets so that you understand it better. Wait. So you realize that, let me put this thing in brackets here. You should have, yeah. Okay. I think this equation, this thing is something else, but let's just, but you do understand what I'm trying to tell you, that this,
Yes, madam, I understand.
this raised to the power half is applying to the whole equation, but this squared is only applying to the centimeter squared. So this half is applying to 169 raised to the power. It's applying to 169. So you have 169 raised to the power half, and you have centimeter squared raised to the power half. So this will cancel this, and then we have b is equal to 169, the square root of 169, which is the same as 169 raised to the power half. And since we've already canceled out the squared on the centimeter squared, we have our centimeter standing alone. So when you use your calculator to find square root of 169, you have 13 centimeters. Then you add your centimeters, and then you are done, right? Or like we did previously, you can introduce your square root straight away, and then this this squared will cancel this, and then you have your b is equal to 169 centimeters squared, which is also the same as b is equal to square root of 169 times the square root of what? Centimeters squared, right? And we know that this square root is the same as raised to the power half. So this 2 here will cancel out this square root here. So our centimeters squared will now be centimeters, not squared. And then our square root of 169 is 13. So you have b is equal to 13 centimeters. Okay?
Thank you.
You're welcome. Any more questions? Any more questions? Okay, now let's solve the exercise we gave out. So we're given, we're asked to find line PT. Kwame Adom, you have a question?
Yes, madam.
All right, let's hear.
Madam, please, can you go back for me? I want to ask something there. Just one step back. So this place. So if I solve this question without the half and those things to cancel the square, and I get the final answer correct, will I be marked right or?
Oh, you don't need to show this. You can simply do it this way. Like we did it here. Sorry, I want to show you something.
Okay.
You can simply do it like this, and we are done. I was only trying to explain further. Probably there are some people who wouldn't understand the step from here to here, how the square root works. So I just took that liberty to go through this. You don't need to go through all this. If you understand how it works, you can simply give me the answer from this square root from here. You understand? From here, you just give me your answer. That's fine.
Okay.
That's fine. Oh, you're welcome. Shiloh, you have a question?
Yes, please. I understand perfectly that AC is equal to AB plus BC. So sorry, BC square and then AC square. Sorry, AB square. So I'm saying that since the question was not given in find AC square, but the formula is AC square is equal to AB square plus BC squared. Does that mean anytime we see find AC or find maybe AB, it means we are supposed to square our formulas?
It means that you apply the formula.
Yes, please. And I'm saying that.
Formula, maybe I'm not getting your question, so make it clear.
You see that it says find line AC, but line AC is not having any squared. So I'm confirming that. I want to confirm that. Does that mean since you are finding AC, the formula for finding AC must be squared, as in AC is equal? Okay.
It must be squared, and then you work out and find line AC without squared.
Okay.
You understand?
Please. Yes, please. I get it now. Please. What about, is there any instance where AC will be given, then maybe you'll be asked to find AB or BC?
Yes, it can be turned anywhere. You just need to have your change of subject, and you just need to know how to group your like terms and then do your change of subject to be able to find because the formula is there. So you can be asked to find any line at any point in time.
Okay, but at this point you realize that when you are finding AC, the operation sign is addition. So when it is turned, is it? Hello, ma'am.
Hello,
ma'am. Yes, please.
Yes.
Please, can you hear me?
Yes, I can hear you.
Yes, I'm saying that at this point, when you're finding AC, the formula, the operation sign is addition. So when it is turned around, is it still going to be addition or the sign will change?
It depends on how when you do your change of subject. For example, if you are finding a particular looking at let me go back and explain how it will look like.
Yes, please.
You see here,
yes,
assuming you were given B, the
yes,
answer
please.
you are given B and you're asked to find C.
Yes, please.
Right? And
yes,
C
please.
is what? Is here. That means that you need to change your subject and then you have to move this here right? And move this here. So it will be 12 centimeters minus 13 centimeters.
Okay.
Do you understand?
13. Please, 13. I'm not getting the
So
13.
B, we know that B is 13
Okay.
centimeters.
Yes,
So
yes.
assuming this is 13 centimeters and we don't know, assuming B is 13 and we don't know this one,
Sure.
right?
Sure.
This one would come here and this one will go here. So we'll
Okay.
have 12 centimeters squared minus 13
Minus.
centimeters squared. And that will
Okay.
give you your BC.
Okay. Yes, please. Thank you.
And I think Kwamina also raised the hand. Kwamina.
Yes, madam. Good morning, madam.
Yeah. Good morning.
Just on this same slide, please. The second, as in trying to solve it, the B squared is equal to 144 centimeters squared plus the 25 centimeters squared. In adding, what happens to the centimeter squared plus the centimeter squared? The 144 centimeters squared plus the 25 centimeters squared is giving us 169 centimeters squared. I'm asking what happens to the addition of these 2 centimeter squares, the one by the 44 and then the one by the 25, or you just go ahead straight?
You realize that this the centimeter squared is attached. It's attached to the number.
That's correct.
It's attached, and this is attached. So you are seeing it like they are together. It's a whole. They are all together. So this plus this, they all have similar units. They are all in the same units. So it is like you are saying 10 kilograms plus 5 kilograms. What will you get? You get what? 15 kilograms.
Okay.
You understand? Okay. So if you have 144 centimeters squared plus 25 centimeters squared, you have 169 centimeters squared. They are all in the same unit. So the addition will also be in the same unit.
Okay. And then which means therefore that finding the square root of B squared is equal to 169 centimeter squared. You can square root all of them, which comes to the next line, which makes B equal to the square root of 169.
Yes, because you realize that this 169, the square root of 169 alone will give us 13. Okay. And the square root of centimeters squared will give us centimeter, because the 2 we have taken the 2 out by cancelling this with the square root. You get it?
Okay, ma'am. We can proceed.
So you have 13 centimeters.
Thank you.
All right. Simon.
Hello, madam.
Yes,
Please, I'm coming again to ask you, please, can you give us the two different formula to get the different size?
I don't get you.
Please, can you give us the 3 different formulas to get the 2 different lines?
Oh, okay. But okay, I can do that. But you should, okay. But you should know how to do your how do you call it? Change of subject. So here, okay,
Yes,
let me
madam.
give an you see here, right?
Yes, madam.
At this point, you can see my screen, right?
Yes, madam.
Okay, let me. So here, assuming we want to find B.
Yes, madam.
We want to find B squared, right?
Yes, madam.
Our B squared would be what? That means that this we have we will have this will have C squared coming here, so we can have can have A squared.
Yes.
Minus C squared.
Yes, madam.
Do you get it?
Yes, madam.
And then if you want to find your c squared too,
Yes, madam.
okay. So are you seeing that?
Yes.
It's just a matter of change of subject or grouping
Yes.
your like terms. You get
Yes.
it? That is it. So here we have just moved for your b squared. We've moved your c squared to here. So
Yes.
you have your a minus c squared. And for the c squared, we've just moved the b squared to, so you have a squared minus b squared. That's okay.
Means the A has to come before the other. If you move the one you bring has to come before the equal.
You said what?
Means if you move E, the A must come after equal. Before the, right?
A
Do you
must come
understand?
after equal.
Yes. To the other one, the left
No,
one.
it's just
The
a
one left.
matter of it's just a matter of positioning. It's just a matter of position. When you look at the equation of the Pythagoras here, right?
Yes, madam. Yes.
Look at the equation of the Pythagoras. Then
Yes, madam.
a squared is what? B squared plus c squared. If you want
Yes,
b
madam.
squared, simply move your AC. You simply move your AC here. When you move
Yes,
your AC,
madam.
you have a squared minus what? C squared is equal to b squared.
Yes.
Is it not the same thing?
Okay, it's the same thing. But I said if like A come here after equal, so B must shift, right? B square must shift. So it will be C square equal to A square minus B square, right? That's what I wanted to know. Because
And
sometimes
C squared is equal to A squared minus B squared.
yes.
You just go and sit down and just practice how you move it about, and then it will help you. Okay. It's
Thank
just
you,
a
sir.
matter of moving it about. Okay.
Thank you, madam.
All right. All right. So can we move on?
Yes, please.
Okay. So let's move on and then let's solve the exercise I gave you. And then we were saying that you should find line PT, right? Find line PT. So here too, you should know that you do a change of subject, like he was asking. We know that this is the equation. We know that line QT squared should be equal to line PT squared plus line QP squared. Okay. So that means that 17 centimeters squared should be equal to T squared plus 15 centimeters squared, right? Okay. So here you realize that I'm looking for t. I'm looking for t, so I have to make t squared the subject. So I simply moved, in making t, I simply moved my 15 centimeters squared to this side. And so I still have 17 centimeters squared minus 15 centimeters all squared. You get it? Okay. Shiloh, can you mute yourself, please?
I'm sorry, madam.
Okay. So when you use your calculator to find the square of 17 centimeters, you have 289. And the square of the centimeters, you have centimeters squared. So you have 289 centimeters squared minus 225 centimeters squared. That is for the 15 centimeters squared. So you have what? You have t is equal to 64 centimeters squared. So you have t is equal 8 centimeters. So our t here, line PT, is 8 centimeters. Right? Okay, so you would have a look at the solution, and I'll give some, there are some questions up here. Okay, Daniel, sorry, Daniel.
Yes, madam.
Yeah.
Please, good morning, everyone. Please,
Good morning.
the equation, as we go to finding the t, like as we have the 17 centimeter square minus 15 centimeter square, can we simplify it by like the 17 centimeter square minus 15 centimeter square, so that we'll have 2 centimeter square before we find the square root?
No.
Okay.
Well, no. You can't do that. You know, we are talking of, all operations have their principles that they follow. So if you don't follow certain principles, it may look like you can do it, but if you do that, you would get it wrong. So here, since it is squared here, you have to do the squared here. Do the squared here. Because you realize if you do your 2 centimeters squared, when you have 2 centimeters squared, what answer do you get?
Then you are going to get 4.
You realize you are wrong. You see, the answer is wrong. So you
Okay.
can't do it like that. Okay.
Yes,
You
please.
have to square it before you subtract.
Yes, madam.
Okay. And Erimid graphics. Please, can we hear you?
Yes, please. Yes, mom. Good morning.
Good morning.
Hello, can you hear me?
Yes,
Please.
we can
Okay.
hear you.
Okay. So please, my question is, during the time I was solving my question, I decided to take off the centimeters from my figures, but at the final answer, I repeated my centimeters. Is it permitted to take off your centimeters, but with your final answer, you bring the centimeters? Is it allowed that way?
Well, I would mark you, but you are a mathematician. So when you are doing it, you do it right. Okay. When you do it right, it makes us understand, okay, you are dealing with it, but it's not bad. So long as at the end of it, you brought it and it is right, it's okay. I would mark you. But next time, ensure you bring it so that we know that you really know what you are doing. Do you understand me? Is
Yes,
that okay?
mom. Yes,
Okay.
please. Thank you.
Felicia.
Good morning, ma'am.
Good morning, Felicia.
Okay, my question has got to do with this same one. And please, we were asked to find PT.
Yes,
But then
line P.
Yes. Over here, your subject is T. But then for me, my subject here was PT. So the answer I got was PT is equal to 8 centimeters. So how about that one?
Madam, I want
PT.
to answer.
Oh, answer.
Okay. Dear sister, please, from the beginning, she taught us that the formulas can be in two folds. That's QPT can be equal to, QT squared can be equal to PT squared plus QP squared. And it is also the same as A squared is equal to T squared
Okay.
plus. Yes. So, madam, I don't know, but I think if you confirm whether I'm right or wrong, but I'm sure I'm right.
Yeah. All right. Right. But you should know that you realize that when I did that, there's line PT here. You see, there are two lines on both sides. It
Yeah.
means that it's telling you line PT. It's telling you line PT. But when I use the T, I'm talking about the exact measurements of line PT. That
Okay.
is all. So if you tell me line PT is equal to 8 centimeters, you are right.
All right. Very well. Thank you.
You are welcome. And then Simon still has a question.
Madam, it's just to, I wanted just to help this my sister, but you have already given the answer. But it's just a T, the small T is replacing just it's like the name you replace the name of PT. That's all.
That's all.
That's
Thank
all.
you.
There isn't anything about.
Yes, thank you. And Bernard.
Yes, ma'am.
Let's hear you.
Ma'am, please. I want to know how you got the 289 centimeter square and then 225 centimeter square.
Oh, you can use your calculator to find the square root of 7.
Okay. Thank you.
The square of 17, that's it. So it's 17 times 17.
Okay. Thank you so much.
You're welcome.
That's what I wanted to know. Thank you.
You are welcome. Shiloh.
Yes, madam. Please, initially, I didn't know the square affects the centimeters and then also affects the figure. So when I got to the third stage, I actually, when I got the answer, the figure, I brought centimeters, but I didn't bring square. But then finally, when I was doing the square root at the fourth stage, which is 64 centimeters squared, I brought the centimeters and did the square root to get my 8 centimeters. So I don't know if I'll be penalized over there.
I don't get your answer. I don't get your question properly. You said you omitted the square.
Yes, on the centimeter square after finding the square root, the square of the number. Please, do you get it?
Yeah, I get it. I'll look at it. When I'm marking, I'll see. And then
Okay,
I'll
please.
see what I'll do. Yeah.
Yes, please.
And there's another hand raised. Wait.
Hello, madam.
Fiddles.
Yes, madam.
Please speak.
Also, when I was doing it, I got 8, but I didn't bring the centimeters.
It's important. The unit is important because we are not talking about length. You understand? But whenever you are talking about length and you have been given the unit, you ensure that you apply your units. Okay. Next time, kindly don't forget. Okay. And then Joseph Bruno.
Yes, ma'am.
Yeah.
Ma'am, this one I can see that
I can't hear
we
you.
have gone wrong. We beg you to forgive. I'm just want to say that we are begging you for what has happened now. so that next time we'll make sure that we'll put on the units. Thank you, ma'am.
All right. Bernard. Bernard. Okay. Who else? Shiloh, where's your hand, please?
No, please.
Okay. So, all right. I think that let's move on and then let's finish and then we can ask more questions. Okay. So let's look at our second question. Let's look at our second question. I hope this one, you all got it right because this is one of the easiest for you. You first find your x. And then I told you that the angle of a straight line is 180 degrees. So what you need to do is that you add everything and then you equate it to what? 180 degrees. So when we add everything and then we group our like terms, we have 2x plus 3x plus 8 plus 12 plus 40, which is equal to what? 180 degrees. And then we have 5x plus 60 is equal to what? 180 degrees. Then we have 5s is equal to 120 because the 180, the 60 will move to the 180 and it will change to subtraction. So we have 180 minus 60 and that will give us 120. So we have 5x equal to 120. So when we want to remove our 5, we want to find x. So you divide both sides by 5 and then you have x is equal to what? 24. Right? We now know that our x is equal to what? 24. Okay. So with the knowledge of we knowing now that our x is equal to 24, you fix it into the equations of the angles. Then you'll be able to get your individual angles. So given that x is equal to 24, then angle QOS will be what? 2 into brackets 24, 2 times 24 plus 8. And that will give us 56 degrees. So angle QOS will be 56 degrees. Okay? Then angle QOR will be 3 times 24 plus 12. And that would give us 84 degrees. And then we know that our angle ROT is what? 40 degrees. Yes. So that is just about it. And I hope you had it. You all had it, correct?
Yeah.
Yes, ma'am.
Yes, we had it.
That's good.
Yeah.
That's good. All right. So that's just about it. And then are there any other questions here?
Yes, please.
Mm-hmm.
All right,
Let's
ma'am.
hear. Mm-hmm.
Please, I have a question from the type of angles. You made us aware that acute angle is less than 90 degrees. So in that case, if a question is being given and it comes with an acute angle, and we are supposed to find the answer, does it mean anything less than 90 degrees is correct?
Were you told? Have you been is this in relation to this question or you are asking on acute angles?
Yes, please. I'm asking
You're
on the acute angle.
Yeah, if you are told that the angle is acute, that means that it should be less than 90 degrees. If you have more than 90 degrees, there is something wrong with your answer.
Okay.
So long as it has been stated that it is an acute angle, then you should be working within 90 degrees, not above it or more than that.
Okay, ma'am.
All right. Any other? Any other question? All right. So without any other question, you are all okay now? Okay. So, Umaru, you have something to say?
No, madam. I just respond your question.
All right. So, Simon, I'm seeing your hand is raised.
Yes, please, madam.
Let's see.
Madam, as you said, the acute angle, for example,
The
to
what?
get acute
Okay.
ankle, to get it amount, maybe if you have a right ankle, to get the right, maybe they say if you have to get 42 degree of acute angle. How can you do to get it?
What is your question? How can you?
I said like the right angle is 180 degrees, right?
The right angle, yes. The total angle
Yes.
is 180 degrees. The
total
angle,
yes.
yeah.
Total angle. Then if the question is asked that you should get the acute angle that 42, for example. Yes.
If you
from
have a right angle,
from the straight angle, how can you do?
If you have a right angle triangle,
yes,
and you have the 90 degrees at the corner,
yes,
that means that
yes,
when you equate, we know that when you have 90 degrees at the corner, that means
yes,
that the other two sides are sharing what? Are sharing the other 90 degrees, because the total is supposed to be 180, isn't it?
It is, madam.
Let me go back to that slide. You are talking of this? Yeah.
Yes, madam.
Okay. So you see here, if here is 90 degrees,
yes,
that means that you have here will be 45 and here is 45. Because
okay.
the total is supposed to be what? 180.
Yes.
The total is supposed to be 180 and you have 90 degrees here.
Yes.
If these two angles are equal,
yes,
that means
madam.
this place will be 45 and this place will be 45.
Okay. Thank you, madam.
You're welcome. Nina.
Yes, please. Good morning.
Good morning.
Okay, I think I don't know for him, but I think the confusion here is that the two angles are 45 each. I think it's not static. It's not always the same that it's going to be 45 and 45.
On condition that they are equal.
Yes, on condition that they are equal. Because this says angle A and angle A, meaning they are the same.
Yes.
Okay, but then it can change depending on the dimensions of the lines.
Exactly.
Okay. All right. Thank you.
Yeah. Welcome. Okay. So this has been a great class. And on that note, if we don't have any further questions, would God willing next week, we'll be looking at length and area of plane figures, and then we'll look at circle, triangle, And I think rectangles are also included. I didn't add that here, but we'll look at rectangles too. So I wish you all the best. There are some hands raised.
Yeah, sorry, madam, to interrupt
Okay.
at this point.
All
Please,
right, let's
our
listen.
previous exercise on percentages and probability, yes, I did it correct, and when we came to class and we solved it together, it was same as what I did, but I was given 1.0 over 10.0.
Are you sure?
Yes, please.
What's your name?
Emmanuel Donko.
Send me a text and I'll look at it because
On
I
WhatsApp.
don't. Yeah, on WhatsApp, and I'll look at it. I'll look at it and see.
Yes.
Because some of you do send this different questions to different platforms, which cannot. If you do that, I can't mark you because assuming you have probability, and then you come and send percentages question there, I can't mark you on that.
Okay, but then it was actually on the requisite platform or page
No
where I was
problem.
supposed to submit.
I'll
Yes,
look
please.
at it.
Yes,
Okay.
please.
Send
Thank you.
me WhatsApp and I'll look at it.
Yes, please, ma'am. Thank you.
You're welcome.
Okay.
Dilo.
Yes,
Tirakia.
Yes, sir.
Dr. Samako here.
Yeah, Doc.
Antirakia.
Yes, sir.
I want to give me maybe 30 seconds to announce that next week and then next 2 weeks is going to be face-to-face.
Okay.
Okay, face-to-face. However, we still have it blended, and those who cannot make it can actually watch it. So
Okay.
thank you very much.
Thank you, Doc. Okay, Nina, you still have a question?
Hello, madam.
I've done my,
Yes.
but I've not been graded. So
Who is speaking? Your name, who is speaking, please? Someone is telling us he hasn't been graded. Who is speaking?
yeah, ma'am. It's me, Vincent.
Vincent, on which
Yeah,
exam? On which assignment?
the one on the platform.
Which lesson? Lesson what?
I think lesson exercise 3 on
It's
no
probably you sent it after I've graded everybody except lesson 4. I haven't graded lesson 4. I'm yet to do that.
okay. That's what I just wanted to find out.
Okay. Simon.
Yes, please, madam. I wanted to ask a question. Those who come late for the courses, and we, like, for example, me, I couldn't get to the assignment that you have given. For example, I did some, I wanted to, but I did it on the paper. But in the system, they ask you to upload the file to send it. So I don't know whether it's only on the computer that you can do that, or it's like how, because I couldn't.
You couldn't upload.
Yes.
And
Because
did you call the IT to
take a
assist
picture
you?
and send it by picture.
You can do that. You can upload. Did you call
It wouldn't work. I don't know.
Did you call the IT for assistance?
No.
Yes, please do that. You should have called the IT for whenever you have certain issues. Kindly call the IT, because for me, when it comes to those technical I am not. So it's better you call the IT and they would assist you. Okay.
Another thing is that like we didn't do the assignments. Can we get right to do the assignment, the assignment that you have given?
Yeah, some of your colleagues also asked the same question. I was telling them that there are all the subsequent lessons have assignments, and you
Yes.
realize that all the most of the lessons have like two or more than one assignment on each lesson. So just
Yes.
do all the lessons, and then that is all. Whatever other lessons you have, just do them, and then we'll pick some of them. Okay,
Okay.
that's all. Because what I'm saying is that all the previous assignments has been discussed, and some of them are even on the videos. So if you go
Yes.
back and then you go and do it and you replicate those ones for me, I don't think it will be fair on those who struggled to do it and then submit. Do you understand me? So what I'm
Yes.
saying is that you don't have a problem. Do the remaining assignments that are yet to come. Do all of them and submit. That is all. Okay.
Thank you, madam.
Asari, you know what? I think that when we meet face to face, we can handle some of these questions. So let's just, if you have any questions, note it and then we'll discuss it when we meet face to face.
Yes, madam.
You are not a member.
What? Daniel?
Yes, please.
Yes.
Madam, please. I think because the reason why some of us are a little bit confused, like when we have more to work our hands on, it will enlighten us more. So some small assignment so that we can be working on it small before we meet for the next
Assignment.
week.
You have a lot of assignments. All lessons have assignments, isn't it?
Yes, but for the mathematics.
So the assignments on the platform are not enough. You want more? You can always
Madam, please have a private class for me.
you want more? No worry. Okay, the next assignment I'll give you like 5.
Yes,
To
madam.
him alone, madam. Not us. You do it for me and for him.
Madam, only him, please, because some of us.
All right. So this has been a great class. This has been a great class, and then I'll meet you next week. I wish you all the best.
Bye-bye.
Bye. Have a good week.
Bye. Same to you.
Bye.
This guy taking generation they play.
Charlie Chema for this study.
It taking generation they play.
I beg, go online and find homework. Go online.
Why? Bye-bye.
Bye.
Bye, everybody.
Okay, thank you all.
All right.
God bless you all. The Christian have a blessed Sunday.
Yes, I am. Yeah, as soon as it's
What time is the general paper starting?
I think 10:15.
Oh, okay.
10:15.
Okay, thank you.
All right. Thank you.
last